Project Tango is a Google technology platform that uses computer vision to enable mobile devices, such as smartphones and tablets, to detect their position relative to the world around them without using GPS or other external signals. This allows application developers to create user experiences that include indoor navigation, 3D mapping, measurement of physical spaces, recognition of known environments, augmented reality, and windows into virtual 3D worlds. The first product to emerge from Google's ATAP skunkworks group, Project Tango, was developed by a team led by computer scientist Johnny Lee, a core contributor to Microsoft's Kinect. In an interview in June 2015, Lee said, "We're developing the hardware and software technologies to help everything and everyone understand precisely where they are, anywhere." Google has produced 2 devices to demonstrate the Project Tango technology, the Peanut phone and the Yellowstone 7-inch tablet. More than 3,000 of these devices had been sold as of June 2015, chiefly to researchers and software developers interested in building applications for the platform. In the summer of 2015, Qualcomm and Intel both announced that they are developing Project Tango reference devices as models for device manufacturers who use their mobile chipsets. At CES, in January 2016, Google announced a partnership with Lenovo to release a consumer smartphone during the summer of 2016 to feature Project Tango technology marketed at consumers, noting a less than $500 price point and a small form factor below 6.5 inches. At the same time, both companies also announced an application incubator to get applications developed to be on the device on launch. Overview: Project Tango is different from other emerging 3D sensing computer vision products, such as Microsoft HoloLens, in that it's designed to run on a standalone mobile device and chiefly concerned with determining the device's position and orientation within the environment. The software works by integrating 3 types of functionality: motion tracking, using visual features of the environment, in combination with accelerometer and gyroscope data, to closely track the device's movements in space; area learning, storing environment data in a map that can be reused later, shared with other Project Tango devices, and enhanced with metadata such as notes, instructions, or points of interest; depth perception, detecting distances, sizes, and surfaces in the environment. Together, these generate data about the device in 6 degrees of freedom, and detailed 3-dimensional information about the environment. Applications on mobile devices use Project Tango's C and Java APIs to access this data in real time. In addition, an API is also provided for integrating Project Tango with the Unity game engine. This enables the rapid conversion or creation of games that allow the user to interact and navigate in the game space by moving and rotating a Project Tango device in real space. These APIs are documented on the Google developer website. Applications: Project Tango enables apps to track a device's position and orientation within a detailed 3D environment, and to recognize known environments. This makes possible applications such as in-store navigation, visual measurement and mapping utilities, presentation and design tools, and a variety of immersive games. At Augmented World Expo 2015, Johnny Lee demonstrated a construction game that builds a virtual structure in real space, an AR showroom app that allows users to view a full-size virtual automobile and customize its features, a hybrid Nerf gun with mounted Project Tango screen for dodging and shooting AR monsters superimposed on reality, and a multiplayer VR app that lets multiple players converse in a virtual space where their avatar movements match their real-life movements. Project Tango apps are distributed through the Google Play Store. Google has encouraged the development of more apps with hackathons, an app contest, and promotional discounts on the development tablet. Devices: as a platform for software developers and a model for device manufacturers, Google has created 2 Project Tango devices to date. The Yellowstone tablet. Yellowstone is a 7-inch tablet with full Project Tango functionality, released in June 2014, and sold as the Project Tango Tablet Development Kit. It features a 2.3 GHz quad-core NVIDIA Tegra K1 processor, 128 GB flash memory, 1920 x 1200 pixel touchscreen, 4MP color camera, motion tracking camera, integrated depth sensing, and 4G LTE connectivity. The device is sold through the official Project Tango website and the Google Play Store. The Peanut phone. Peanut was the first production Project Tango device, released in the first quarter of 2014. It was a small Android phone with a Qualcomm MSM8974 quad-core processor and additional special hardware including a fisheye lens camera, RGB-IR camera, and Movidius image processing chips. A high-performance accelerometer and gyroscope were added after testing several competing models in the Mars lab at the University of Minnesota. Several hundred Peanut devices were distributed to early access partners including university researchers in computer vision and robotics, as well as application developers and technology startups. Google stopped supporting the Peanut device in September 2015. As by then the Project Tango software stack had evolved beyond the versions of Android that run on the device. Testing by NASA. In May 2014, 2 Peanut phones were delivered to the International Space Station to be part of a NASA project to develop autonomous robots that navigate in a variety of environments, including outer space. The soccer ball-sized, 18-sided polyhedral spheres robots were developed at the NASA Ames Research Center, adjacent to the Google campus in Mountain View, California. Andres Martinez, Spheres manager at NASA, said we are researching how effective Project Tango's vision-based navigation abilities are for performing localization and navigation of a mobile free flyer on ISS. Collaborators and partners. In creating Project Tango, Google has collaborated with developers in 9 countries including Bosch, Square, Compalcom, ETH Zurich, Flybe Media, George Washington University, Solutions, Movidius, University of Minnesota Mars Lab, JPL Computer Vision Group, Alogic, OmniVision, Open Source Robotics Foundation, Paracosm, Sunny Optical Technology, Technologies, Mantis Vision, PrizeMeek, and Sajiv Tech. Partnerships have been announced with companies that include Apolab, Autodesk, Al411, Bosch, Defective Studios, Deravis, Infineon, JPL, Left Field Labs, Limbic, Mobac, NVYVE, OmniVision, Otherworld Interactive, Technologies, Sajiv Tech, Sidekick, Spec Design, and Stink Digital. External links, official website, Project Tango developer site. Project Tango developer community. Project Tango smartphone development platform page at Qualcomm. Intel expands developer opportunities as computing expands across all areas of people's lives. Intel Developer Forum. August 20, 2015. Google and Intel bring RealSense to phones with Project Tango Dev Kit. Engadget. August 18, 2015. Google I/O 2015, Project Tango, Mobile 3D Tracking and Perception. Johnny Lee, Google I/O 2015. YouTube May 29, 2015. Project Tango Concepts. Johnny Lee, YouTube April 21, 2015. Project Tango Tablet Teardown. iFergsit. August 15, 2014. References